Okay. Today we're going to learn the chapter 9 on rates of reaction.
Okay.
Okay. So rates like how fast. Like how fast. Okay. How fast it happens.
Yeah.
So how fast it happens. So it's mean like produce products or consume reactant.
Yeah.
So how fast it happens is mean. So this one, let's say like mole, for example, mole, and then how much mole like divided by time. Okay, and then we're going to look at the effect of concentration on rates of reaction and the effect of temperatures on rate of reaction, and then finally we're going to discuss about the role of catalytic in chemical reaction. So catalytic normally is accelerate the reaction. So look like the graph here. Here the concentration on the vertical axis and the time on the horizontal. See, so over time the amount of product increase. Okay.
Yeah.
So over time, you see this one, right?
Yeah.
Amount of products increase. Okay, in contrast, you see the amount of reagents decrease over time. So decrease over time.
Yeah.
Okay. So just look at the term and see if you are familiar with them. See, catalyst. What is a catalyst?
Just substance to speed up the reactions.
Yeah, a substance. Speed up. Okay, so accelerate
Yeah.
reactions. Rate of reaction. Okay.
Yeah.
So rate of reaction is like how fast the
Yeah.
reaction consume reactant or produce product. And then collision theory. Okay.
Just to predict the rate.
Yeah. Collision theories. We use the theory to explain why this reaction happen quickly or slowly. And we based on the collision amongst reactants.
Yeah.
Limiting reactants. So limiting reactant decides the rate of reaction. Okay.
What can you explain like more specific?
Okay. It decides the rate and the yield. For example, if you have some reaction happen between like CaCl plus NaOH, and then it going to create like NaCl plus water, right? So suppose you have like 2 mole here. And this one you had just 1 mole. Okay.
Yeah.
So the maximum source NaCl here you produce by this reaction is 1 mole. Because okay, so NaOH is limiting. Understand?
Yeah.
Because you still have 1 moles, we still have 1 moles. of HCl's in solution, but it does not like produce more products. Get it?
Yeah, okay.
So activation energy, what it does? Activation energy.
Activation energy.
So it's energy that the reactant needs to gain to
To like
to react with other reactant. So it kind of like a barrier. So you can say like energy barrier that reactants must overcome to react with other. Okay.
yeah.
So if the reactant cannot overcome this energy barrier, then the reaction is not going to happen. Kinetic energy. Kinetic energy.
The energy of motions.
Yes. Frequencies of collisions. Frequency of collisions. So it's the number of collision per a unit of time. You can say like a second, for example. 1 second, how many times the reactant collides with one another.
Yeah.
Okay, so rate of reaction is talking about fast, slow. So look at this one. You see the firework. So chemical reaction here is must be very fast. Fast to maintain. Okay, fast to maintain a continuous. Okay.
Yeah.
Continuous like view or thing like that. Okay, files, lights, so a lot of things like this. So it must go fast one after another. And the erosion or corrosion of the ship here is slow because it's happened over many years. So some reaction must fast, some reaction it can happen slowly.
Yeah.
But the same thing happened to the engine of the car. If you look at the engine of the car or the bottom of the car and so similarly it can happen in like in car. Some part like it seems like never going to corrode, but some part corrode slowly over like 10 years. Some part of the car corrodes. Okay, so rate reaction is talking about how fast, how slow a reaction takes place. Okay, a study of rate chemical reaction is called reaction kinetic. Okay, so rate of reaction is change in amount of reactant over time. So you can say that dentar, okay, dentar, maybe concentration or amount, whatever. You can see like times. Unit of concentration. So if you have mole per liter and then time and then the final is unit, it will be moles. And then it can be minutes. Okay.
Yeah.
Or it can be second. or it can be hours. So as long as time, fine. So normally the rate reaction normally moles per decimeters minus 3 are over second. That's it. So that rate of reaction. So you understand the change in amount of reactant. So reactant will be the amount of reactant will be decreased over time, and the amount of product like increase over time. So that's what's going to happen.
Yeah.
So look at the question here. Convert the following rate into unit of mole per second.
The first one I just take 0.254 over 1, right?
Look at this unit here, gram. So
Oh,
you must divide for 2 times 127. So you get the mole. Okay.
oh, okay. Yeah, okay.
And then let's see, divide by
Yeah,
time. How much? Like 1 hour. 1 hour 60 minutes. So it's times 60. So
yeah,
3,600.
yeah, okay.
You get it? Here is second. This small.
Fractions, like what
Same here.
what is 2 times, where is the 2 come from?
Because one eyes is 127, but here I2.
Oh, okay. Yeah,
Yeah,
yeah, okay.
that's it.
Okay.
Okay, look at B.
B,
So first you need to change something.
yeah, 400 centimeters.
Okay. So for B, for let's say meter cube. So it
For
will
the,
be 0.4,
yeah, 0.4.
right?
Yeah,
And then similarly, you going to calculate the mole. Mole C3COO if equal 0.044 and divide by that one.
yes, 88.
Yeah. So you have the mole, and
Yeah,
then you calculate the raise. It means you have the mole. You divide by 1
second.
minute. It means 60 seconds.
Yeah,
Some
and
here for 0.4.
what we need to, I thought that would just take the first answer and then divide by 60.
How about the volume? Because you see the unit here.
Okay. Yeah.
You get it?
Yeah. That makes sense. Okay.
So what mistake you made here?
Mistake.
Yeah. So did you make any mistake here? Yes, no,
Uh, I think no.
no,
Yes. I think no mistake.
no mistake. Okay. But you forgot this one, right? The 127.
What? 127.
At first, you use the number. You use the number 254. You divide. So you didn't convert into mole. Is that true? It's okay. I lie. You recognize the mistake if you make, so that next time you're not going to make it.
Okay.
Mm. Okay, calculating the rate of reaction graphically. So the same with the formula rate of reaction, like the chain of amount over time. So here in this reaction, it's from cyclopropanes to propenes. And then you see here the concentration of product increase over time. So concentration increase here. And this time, 40 minutes. So here we have products. So if you say, if you get like 5 seconds, so this point, this position, 5 here. So I write like 0.2, 27, 28 something.
Yeah.
So the answer is there, like divide by 5 seconds. But if you take another one, it might be different. For example, if you take the 10 second here,
Yeah.
then you get different number. Maybe 0.5, 5.1 or something. 0.5, 5.2 divided by 10. You get like 0.552 divided by 10, for example.
Yeah.
Then you go into 0.052. But if you take some range here, so this one is like 10 seconds, and this one is going to the chain in concentration is very weak here. So here only like 0.2 or something, 0.2 and divide by 10. So it goes to 0.02. Yeah, 0.052. So see the rate of reaction is not the same. You get it?
Yeah.
So the reaction might become like slower when the reaction happen over time. In this case, so by using the graph, you can calculate the rate of reaction, and this is what we call rate of reaction graphically. So the method. Okay, change in rate of reaction as reaction proceed. So over time, the rate of reaction like change. You see here, for example, at beginning, the rate is like 10 minus 3. This at first. The first, at first, at beginning.
Yeah.
And then this one in the middle, this last at the end, right? We can say, so this one is about 30 minutes. In fact, this one is about 10 minutes. This one is a beginning 10 minutes, and this one is like 28 minutes. So if you calculate the rate of uh, reaction is somewhere here, then it might be slower at the end. So see, rate of reaction like decrease, not the same over time.
Yeah.
Okay. So rate decrease of cyclopropane and over not the same. Okay. After the rate of reaction, we're going to see the collision theory. So how we going to explain? So in order to react with it, other particles must collide in the correct orientation with sufficient energy. Okay, so it must collide in correct orientation with sufficient energy. And the particles might be atoms, ions, or molecules.
Yes.
So that the reaction can happen.
Yeah.
Okay. So that is collision theory. So there are two things here. Correct orientation and then sufficient energy. So when this happens, the reaction happens, and we call it an effective collision, a successful collision. Otherwise, uh, if the collision take place but no reaction take place, it means the collision is ineffective.
Yeah.
Okay. So here like one like no reaction, but this one yes. Okay. Let's see. Ineffective and effective. It depends on the orientation and the energy that reaction take place have. So sufficient energy here, you can see the connection with activation energy.
Yeah.
So activation energy is the energy at beginning. Reactant have so that when it collides, it can react successfully. So we come to activation energy. So this part we call it activation energy here. This one. So normally we see in many books it say EA, activation energy. So we call it startup energy. So the minimum energy that colliding is particle must possess for collision to be effective. Otherwise, it's not going to happen.
Yeah.
And this one is in exothermic reaction. In activation in an endothermic reaction, different. Yeah. Okay. Yeah, the reaction back way. Okay. And this is the unique. The unit so kilojoule, kilojoule per mole, kilojoule per mole. when a reaction speed up. Okay, when a reaction speed up. So there are two. Frequency of collision increase, and then proportion of particle with energy greater than the activation energy increase. So remember frequency. Okay, so per unit of time, the number of collision per unit of time increase, and then the number of particles that have energy equal or greater than the activation energy increase, and then more particle can uh, participate in a reaction. Yeah.
Yeah.
Okay. So when there are more particle with like enough energy collide. Okay, the last part of this chapter is catalyst. Okay, a catalyst is what? A substance that increase the rate of reaction, but
Yeah.
normally it doesn't change at the end of reaction. It come back. So you see the role of catalytic reaction here. So here you have like 2EA, 2 activation energy. This is the normal, this weak catalytic. So it's bigger. So that's reason why we catalyst, the particle need smaller amount of energy and chemical reaction can happen. So catalyst save energy for the reaction to happen.
Yeah.
Okay. So what do we mean by the activation energy of a reaction? Can you answer it?
What is activation energy? Okay. So the amount energy like uh need to like activate.
Yeah, it's the minimum amount of
Yeah.
energy that the particle need to have
Yeah.
so that it can collide with other particle effectively or successfully. Okay, what a catalyst?
It's just substance to speed up the chemical reactions.
Okay, how about the C?
Okay. Um, I think like B, like it decrease.
Decreasing the activation energy.
Is that right?
Yeah.
Oh, okay.
Okay, can you explain D?
Using collision theory explain. So if the surface area is increased, so it will let the particle to like collide,
Yes.
and the faster of a reactions will will happens.
Okay. Yeah, it means the increasing the surface area, increasing the surface area. So S increasing, so it will increase the active side,
Yeah,
increase active side. Okay,
yeah,
on the reactant.
yeah,
So that it can increase the frequency of collision.
yeah,
Frequencies of collision. Of effective collision, you can write effective collision, so that it can increase rate of reaction. So when we increase the surface area of solid reactants, it means it's increase the active site on the solid reactant available for more effective collision, and then it's increase the rate of reaction as a result. Good.
yeah.
Okay, let's look at what is the effect of the concentration on rate of reaction. In figure A and B, you see in A you have more reactant and B less reactant. So in A high concentration, okay, like C here, CA like higher than CB, for example.
Yeah,
So in A, so in box A has more reactants, so the probabilities of collision is higher, and then the frequency of effective collision is higher. So that is the role of concentration. When you increase the concentration, it means you increase the number of particles in the reactor. So there are more collision. So the chance of uh, effective collision is higher. Okay, look at the question. Dilute hydrochloric acid react with maple chips, giving off carbon dioxide gas. So which solution do you think? A, B, C?
uh, I think A.
A.
It had more surface area. Right.
very
50.
dilute. So I mean doesn't have, what is the highest concentration? The highest concentration is this one.
Oh, one. Yeah, yeah.
So it should be
B.
P.
Yeah.
So it's blend. So we can use the box. So higher concentration,
Uh, higher concentrations.
so higher frequency,
Yeah.
collision. Yeah,
Yeah.
okay. Then increase the rate of reaction. Here you can write, here you can say like increase the, effective collisions. Clear?
Yeah. Yeah. Clear.
Good. Okay, look at the next questions. Which one of these explanation about the effect of increasing the concentration of the reactant on the reaction is correct? So remember, this one is must be completely. Which one? A, B, C, D?
Uh, Reactions. I think D.
D?
Yeah.
D.
D.
So you choose here, this one, right?
Yes.
Okay, I choose C.
So the correct answer is C.
Yeah,
Wait.
look at
Greater.
D. Look at D. Something wrong with it?
The particle have greater collisions. Oh. Oh, D is because. Oh, okay.
Because they collide more effectively. You see it's
Yeah.
wrong
Yeah.
there
D
already?
is correct.
So you see here C, it's closer, yeah? Higher concentration is mean the particle is closer. And they collide more frequently. Is that correct?
Yeah. Yeah. That's correct.
A is wrong because it's energy. This one is wrong. This one is wrong here. So what's wrong here? This one is missing. It should have like, it should mention frequency, frequently. Frequencies. Effect of temperatures on rate of reaction. So what happens when you increase the temperature?
Uh,
So in a sample of molecules, there are one part uh, of molecules that have enough energy to cause a chemical change when they collide. Okay, you get it?
yeah,
Let's say this one like X percentage. The whole thing is 100%, but only a small amount X of molecules that have enough energy to collide effectively so that the chemical reaction can happen. So when we increase the temperatures, X increase, so it means more chance for chemical reaction to happen. So see like T decrease and then T10 mean like 10 degrees higher. So here is more chance. So the number of molecules that have enough energy for effective collision increase. So there are more chance for chemical reaction to happen. Okay, you get it?
yeah,
So more particles or more molecules that has enough energy to collide effectively. So that's the reason why we increase the temperatures, we increase the rate of reaction, because the particle move quickly. So increase the frequency of collision, and the percentage of successful collision increase. So that is come to kinetic energy. It's move faster, more higher energy.
yeah.
Okay, look at question. What is Boltzmann distribution? Explain why 10 decrease rise in temperature is approximately double the rate of reaction. Okay, I already explained here already. You see the jet area of this say
Yeah,
area, so it's bigger than the other. And Boltzmann's, okay, the distribution of energy at a given temperatures. Catalyst. So catalyst increase the rate of reaction because they can make the reaction go by a different reaction pathway. So
yeah,
lower activation energy than an uncatalyzed reaction. So catalysts have reduced the the energy that the particle require to collide effectively. So with catalyst, activation energy is smaller.
yeah,
Okay, this one I might send you at a homework for that part.
Okay.
Homogeneous and heterogeneous catalysts. So it's mean there are two kind of catalysts. Okay, the catalysts that are in the same phase with the reactant we call homogeneous. So this one like the same phase.
Yeah.
The same phase as reactant. So phase here it can be liquid, solid. More of the time you see like liquid and solid. Heterogeneous catalyst is a different phase. So for example, it can be like a different phase. So if reactant is liquid, then
Yeah.
catalyst is solid, for example. Okay,
Yeah.
so different phase. So so it depends on the kind of reaction, chemical reaction that we use. Yeah, here you see some example here. Reaction commonly used in laboratories of the composition of hydrogen peroxide. For example, this one is slow reaction. But if you add manganese oxide power at the catalyst, then reaction take place very fast. So in this case, hydrogen peroxide is liquid, but manganese oxide is solid. So manganese oxide is a heterogeneous catalyst. Understand? So see here, like it's choose is liquid, and
Yeah.
manganese oxide is solid. Okay,
Yeah. Okay.
is heterogeneous. Good.
Yeah. Good. Good.
You understand?
Yeah. I understand.
Good. So I think today we stop here.
Yeah. Okay.
Okay, and I see you on Monday.
Yeah. Okay.
Is that good?
Yeah. Good.
So we almost finished the chapter 9. This time we run very fast. It seems like you understand well this part already.
Yeah. This is some IG stuff.
Yeah, that's
Yeah.
right.